Hi guys. So for today's lesson, we're going to be dealing with compound interest and depreciation. Okay, so first things first, what is compound interest? Well, compound interest is a type of interest, so similar to simple interest, which is another type, but this sort of interest is calculated on the principal, which was similar to simple interest. It was calculated on the principal. However, it's also calculated on any prior interest as well. So with compound interest, you're pretty much getting interest on your interest that you've already earned. Or for example, if you're borrowing money, you're going to have to pay extra interest. Well, the amount of interest that you have to pay in the future builds up on top of that interest, which is already accumulated. Okay, so for example, say if you've got an investment of $5,000 at 10% per annum and it's compounding annually. So that pretty much means, when I say compounding annually, it means that extra interest is being put into the investment each year, or it happens once a year. So for example, let's say in the first year, you borrowed your $5,000 and your investment is going to go up by 10% of your money that you've invested, because it was 10% per annum. So 10% of $5,000 is 500. So you pretty much got your investment of $5,000 for that first year. You get an extra $500, 10%, and that comes out as a total of 5,500. So that's just what happens in the first year. In the second year, you've got your 5,500, because that's what you got at the end of the first year. And then you get your 10% of your money. And the money that you're getting 10% of includes that interest that you just got. So whereas with simple interest, that would just be the original $5,000 you invested. It wouldn't include any extra interest. So 10% of this amount now, 5,500, that's $550. And so you add that on to the money that you already had in that account, the 5,500, and you get the value at the end of the second year. So then you would find 10% of this new number and add that on to 6,050. So that's the sort of pattern continues year by year, and that's what compound interest is. Notes, the compound interest formula. So there's a special formula that helps you out to figure out these sorts of numbers. It allows you to quickly determine the value of a loan or investment for any number of years or months, etc. So it's just a nice, quick way to be able to come up with these values for the value of an investment, or the value of a loan or something. So the compound interest formula is this. You're dealing with P, R, and N in this formula. So P is the principal, similar to simple interest. It's the amount of money that you invest or borrow. R is the interest rate, and it's important that you remember that it's in decimal form. And N is the number of time periods, very similar to simple interest, I equals PRN. So yeah, the number of time periods is like the number of weeks or years, etc., that you're investing or borrowing for. However, there is a bit of a difference with this formula. You need to note that the interest rate R and the number of time periods N, so these two things, R and N, they need to match. And that was the same with simple interest, but they need to match the compounding rate. So in each question, I will tell you how often it's being compounded, how often interest is being put into these sorts of accounts, into these sorts of investments. So compounding annually means once a year. Compounding biannually means twice a year it happens. Compounding quarterly means it happens 4 times a year. And compounding monthly means it happens 12 times a year. You could also have things like compounding weekly, which would be 52 times a year, or fortnightly, which would be 26 times a year. It could even be daily, which is 365 times per year. So you've got to remember these sorts of numbers for these sorts of compounding rates. So next word we need to know is depreciation. So that's the process in which an object decreases each year by a certain percentage. So instead of value increasing by a percentage, which is compound interest, it's now decreasing. It's the opposite process of compound interest. So the formula for this is exactly the same. However, instead of a plus here, it's a minus. Okay, so let's do some example questions on this. So $20,000 is invested for 5 years, compounding annually. Really important there. It's compounding once a year at 7% per annum. So what is the value of the investment after these 7 years, not 5 years? So let's just quickly change that. So I want it to be 7 years. Okay, so what is the value of the investment after these 7 years? Okay, so let's have a look. We use the formula first up, but we need to make sure we're using this formula properly. So first up, our principal is our $20,000, the amount that we're investing. Our rate is our 7%. And converting that to a decimal version is going to be 0.07. Our N is our 7 years, and we need to realize that our compounding rate is an annual rate. So it's really important to understand that we need our N and our R to match this annual rate, this yearly rate. And it does match because we're dealing with years, and our percentage is a per annum year. So this PA means per year. So it does match with our compounding rate of annually. Okay, so now that these match, we use these numbers into our formula. So we've got this formula here. Our P is our principal, $20,000. Our R is our 0.07, our decimal version. And our N is our number of years, and that goes there. Now that N, this tiny little 7, that's a power. Really important that you're putting it in as a power in your calculator, and it should come out as $32,115.63. Make sure 2 decimal places with money. So your investment of $20,000, you've invested that money for 7 years. If you wait that 7 years, it's going to end up being $32,115. So you pretty much didn't have to do anything with this money. You pretty much just had to put it into an account and leave it, and it'll automatically turn into this much. So you can see why a lot of people like to invest, because it's easy money. You don't have to work for it. It does the work itself. Okay, question B. How much interest was earned in this investment? So the idea is that the interest of this investment is pretty much the final amount, take away the original amount, the principal. It's like pretty much how much did our original amount change by? So how did our principal change to our final amount? By how much? So you find the difference between them. So that was our final amount, that was our original amount. So the difference between those is roughly $12,000. So that's all interest that has been accumulated by this investment. So it's an easy $12,000 over 7 years. Not bad. I would definitely take that sort of money. Okay, so question 2. Determine the total amount that needs to be repaid if $45,000 is borrowed for 10 years at 12% per annum, compounding biannually. So our first question A, we want it to be compounding biannually. That means twice a year, or half yearly is another way to say biannually. Okay, so first up, we need to figure out that our compounding rate is this biannually, half a year, so it happens twice a year. So we need to make sure, well, first up, let's do our principal, which is our $45,000. And we need to now make sure our R and our N match up with our compounding rate of half a year, or 2 times a year. Okay, so our rate is 12% per annum, but we need to convert that to half a year. So we're going to divide it by 2. So our 0.12 in decimal form, if we divide that by 2, it comes out as 0.06, and that's for half a year. That's exactly what we need for our biannual rate. And next up, we've got our N. Now, our N is 10 years. we can see here 10 years. But we need to go from years to half years. So the idea is how many half years are there in 10 years? Well, the idea here is to now multiply by 2. So you're going to get 20 lots of half a year in 10 years. So a bit of a trick is you can figure out that biannually means twice a year. So you can divide this part by 2 and you can multiply this by 2 and you get your correct values. Okay, so using our formula, our P changes to $45,000, our R changes to our 0.06, and our N changes to our 20 half years. So our 20 goes up there. So we put this into our calculator and we get this value for the amount that needs to be repaid. Pretty much the idea is you're borrowing $45,000, you're going to end up repaying this much. You're going to pay significantly more than you borrowed. And the reason is because that's how banks, etc., make their money. They pretty much get you to borrow these large amounts and have to pay heaps more in interest, and the bank gets all that profit. So that's the amount that needs to be paid off right there. Okay, let's try it again, but instead of biannually, let's try compounding weekly. So this means that interest gets put into this account, like our loan will increase every single week with interest. Okay, so let's give it a shot. So our compounding rate is weekly. That means it's happening 52 times per year. Our principal is still going to be the same, $45,000. Our rate is still 12% per annum, but we've got to now divide it by 52. We've got to make it so it's a rate just for 1 week. So we've got to make it go all the way down to just a rate per 1 week. So we divide it by 52. If I put that into a calculator, it's a terrible decimal. So you want to leave it actually looking like this in your calculator, because otherwise it becomes a really long, awful decimal. So that's okay. Next up, we've got our 10 years. Obviously, we want to go from years to weeks, so it matches up. So we multiply by 52 in our 10 years. That's the same as 520 weeks. So we need to be multiplying here, remember. Okay, so now that we've got our values, that value, and that value, we shove those into our formula. So our P is 45,000, our R is this fraction here, and our N is 520. So if we put all that into a calculator, it comes out as $149,000. So that's the amount that needs to be paid off. Have a quick look. If it was compounding biannually, so remember biannually, we're only having to pay off $144,000. But here, we have to pay off $149,000. The idea is, if you're compounding more often, you're putting more and more interest in more often, even though it doesn't make too much of a difference how often you compound the interest, really, it does make a small amount of difference over a long period of time. So you can see here that because we're compounding more often, it's going to make a difference of about an extra $5,000 over the 10 years. So it does make a bit of a difference. So if you're borrowing money, guys, you want to be compounding as little as possible. But if you're investing money, you want to be compounding as much as possible to get as much money out of it. Okay, and one more question. A car is said to depreciate by roughly 20% per year. How much will a $30,000 car be worth after 4 years? So that is the case. I'm pretty sure cars do roughly depreciate by about 20% per year. So the way to do this is to firstly think about your compounding rate. You want to assume that it's a yearly compounding rate. They don't usually specify in depreciation questions. So our principal is the value of the car initially, $30,000. Our rate is 20% per annum. We want to change it to decimal form, so that's 0.2, and that is a yearly rate, so it does match up. And our N is after these 4 years. So our N is going to be 4, and that's in years, so that matches up with our compounding rate. And so we use these values here straight into our formula. Now make sure you're using this formula here. So with depreciation, instead of a plus, it's a minus in the bracket. So $30,000 at the front for P. Our R changes to 0.2, and our N changes to 4. Now notice, guys, we do like to simplify these brackets. I know you could just shove that straight into a calculator, but for some multiple choice questions, they do like to give you like one of these options and say which one is correct. So if we do the bracket first, 1 take away 0.2 is the same as 0.8. And so this thing is exactly the same. That can go into your calculator as well. So it comes out as $12,288. So your $30,000 car goes all the way down to this value only after 4 years. So cars do depreciate very quickly. And so, yeah, that will be its value after 4 years. Hope this helps you out with the questions. Good luck. Bye.